Yeah, now this is recording as well. Okay, I'll share you the link. Okay, now if we are done with this, so NumPy, we saw the how to create an array, how to look at slicing, and what all different things we can do. We can iterate an array, so basic of NumPy we were able to do, and we also saw the shape and all those things. Now there are many other functions also. I'll show you very simple ones. Let's say you have an array np dot array, and let's take 1 2 3 4 5. Okay, this is the AR. Now we can use the np dot where ARR is equal to, let's say, 4, be equal to, let's make this 10 20 30 40 50. Let's check for 40. You see, this gives back the index of where this element is present. So using this, you can actually, search elements in an NumPy array. Make sense? Okay, this is fine. Now for sorting an array, it is very easy. You just use np.sort, and you just put in the ARR, whatever is the NumPy array, so it will sort. And if you want to do it in the other order, you can also check that. There's also an order that comes there. Now what one more thing that you can do is, I'll show you one very nice thing. Mm, let's say you have some NumPy array, and you want to sort using uh, any separate thing also. You can also do that. So let's say you have NumPy array. Okay. Okay, now it is working. Fine. Let's say np dot array, and you also have, let's say, alphabets. So you can also sort, alphabets like this. You see, this got sorted. So like this, you can sort even the arrays, and I think that is most of it for. Oh, sorry, this is not. No, no, this is not sorted. See, you see, Z is coming before Y. Now you see, now it is sorted. Fine. Now it is sorted. Fine. Now I think NumPy is mostly done. The basics of NumPy is mostly done. Now we'll come back to advanced of NumPy when required. Okay. Now let's move to pandas for now. Okay. So now we will move to pandas. Let us insert some text here. Pandas. Okay. Let's remove this. So like you do NumPy, you also import pandas as PD. Okay, which is pandas data frame, and using a dictionary. So like NumPy was what? It was similar to a list, and a one-dimensional list, two-dimensional list, or an array that you would have used in Java. But pandas is more of when you use Excel. You would have used Microsoft Excel or Google Sheet. So consider pandas of more of like that. So like there was in NumPy, there was a list. Similarly, in pandas, you have a series. Okay? And let's say arr is equal to np dot array. We create an array, fine, and we convert that numpy array to a pandas series. Okay, so we can also convert any numpy array to a pandas series if it is one dimensional. Okay, but now see one thing: if this was like this, you know, if this was string, then what would happen? Homogeneous. So what would happen? Everything would be converted to, you know, you see everything is converted to string. Now instead of this, if we used pd dot series, okay, pds, and let's say we can also use a list to form a pdo dot series. Okay, it's not necessary you every time need a pandas data frame only. If we do like this, so now you see what happens. Type is what? Object. Okay, d type is object for now. Now let's see once. You see 0 is 1. Okay, now let's see 1. You see this is string. Okay, what we can do is, let's say for I in PD, you'll also start understanding loops, PDS, and print the type of I. The type, initially it was integer, then it's string, then int, then int. This means panda series can hold heterogeneous data type. Fine, makes sense. This is why pandas is, an extension of, what you can say, numpy in this aspect. Okay, very good. And this is just like, we use a column in a table, in, let's say, in your excel, you use a column. Similarly, you have a column here. Okay, this is a pandas series. So here, sorry, column is this only, this whatever is inside pds. This is like one column in a excel. This is similar to a column in an excel. And you see you have 1 to 5 here, plus you also have something 0 1 2 3 4. What is this? This is like the, like we had the index for numpy array, है ना? We had the index 0 1 2 3 4 5. Every time it started from 0. Using that index we can, uh, access any element in numpy. Similarly here we have this index, and let's say pds, we provide the index 2, then what will come? 3, है ना? Now one interesting feature in pandas is, see this, what I'll do is, let's say I have 1 2 3 4 5. I can also provide the index a b c d e. pss I have written. Now if you see pss, you see the index has changed. Now you will not refer the elements like this. If you try like this, oh, this would also work and that would also work, because this is a series as of now. In a data frame, then game would again change. See, now let's say you put anything, p was not there, so it would give an error. But a is there, so we have now changed the index. So we can put anything in the index. This can be a b c d e or anything, whatever you want. Fine, very good. Now we can also convert, any dictionary to a panda series. Let's say you have this dictionary. Let's say uh, the name of the student and his marks. Let's say name is Akash and marks are 10. Name is Isha, marks 20. Name is Mayur, Mayur, marks is 15. Okay, let's see what happens. Now you see the key value of the dictionary automatically becomes the index for the panda series, and the value becomes the actual values. Now let's save this. Now if we want to access the marks of Akash, we can also do like this. Make sense? Okay, so this is pandas series. Now using this series, like I said, this is like a single column of a, here let's say Google Sheet or your Excel. Now we move to data frames, and these are very interesting. Let's add some text. Now this is very interesting. PD dot data frame, and this is like one of the most widely used data structure. Let's say now you will have multiple columns. Initially you were just having one column na? Now let's say the name of student and the marks, fine, and these two can be arrays. Let's say name is again Akash, Isha, Mahur, marks are 10, 20, 15. Another we can have class, or you can say section. Okay, section can be, let's say, A, A and B. Fine. Now you see DF. Using this type of syntax, we can form a pandas data frame. I'll show you. See, in series, now you see, in series we had just one column, name column, marks column, or section column. But in data frame, you can have multiple pandas series. So these individually are pandas series. Okay, makes sense? And because series is heterogeneous, so every column of this data frame can be a heterogeneous pandas series. So let's say marks here are 10, 20, 15, and here you put it, let's say a string ABC. So what would happen? But the length should be same, because here you added 4, so here also there should be 4. Let's say Pala. Now you see here, now you have 10 also, 20 also, 15 also, and ABC also. So this is data frame made of several pandas series. Now like pandas series had an index, data frame also has an index. You see the 0, 1, 2, 3. This is the index. Okay. But using, let's say you do 0, just doing 0, it would give you an error. Okay. So first you need to take the pandas series. So this is also, see, this is one index. So this is the row index, and this is like the column index. है ना? So there, these identify which column we are using. Like visualize the NumPy 2D array. We had the rows and the columns, but there the what indexes were there? Zero and ones. Any numerical indexes were there. Here the indexes can be anything. Strings also, numerical also, or any value. So first we get the name of the column. Let's say name or marks. Okay, so this will give you this column. Now you can access the value. See? So first the column index and then the row index. Fine? Make sense? Good. And similarly, slicing also you can do. See, like this. You know, all the slicing that you were able to do in NumPy, same slicing is also possible with Pandas series. So this essentially is a Pandas series. This part. Now with this series, you can do anything. You can also do slicing. You can similarly, like we were doing all the aspects in NumPy, all those features are available here also. Only difference is there the index were fixed and the data was homogeneous. Here the index also you can change, and the data is also heterogeneous. And you can also take, let's say now, section is another Panda series. And here let's say now we move from -1 to 0, and we go, oh sorry, it's -1. So you see CBA now in a reverse order. Yeah, makes sense. So this I had shown you in NumPy. Na, we start from the last index, -1. This is the starting index, na, and we go till 0. We go till 0, but actually it will go till 1 before 0. So you can put -1 to see everything also. I'm sorry, not -1, 0 till tak it will go. So C, B, and A. It goes to C, B, and A. And if you don't provide anything, C, B, A. So this is how we were reversing the NumPy array, if you remember. We provided the step count to be -1. So similarly here, we start from the end, we go till the beginning. If nothing is specified, it means the whenever it the element doesn't ends, and this is the step count. So we go in the reverse direction. Fine, good. So we have also seen this. Now you can also use, uh, you can also change the index here also. Like this is 0, 1, 2, 3. Now you can change this index also. That is also possible. So let's take this data only. Okay, pandas D and D. Now see, the index has changed. So now if you want to get, let's say, this data, 15. So how will you get it? Marks, then what? C. Very good. So you can use this, but 0, 1, 2. Okay, both notations you can use. Fine. Okay, great. So this is this. Now we can also go here. We can, so now df dot columns will give you the name of the columns. You see, there are 3 columns in name, marks, and section. And as I told you, this is an index object. So these are the indexes of the columns. These are the indexes of the rows. Fine. You can also change the name of the columns. Let's say df dot columns. If you want to change the name of the column, so you can say name, student name, and student marks, and student section. Okay, let's say you want to change the name. Now you would see the name of the column has changed. See, you know. So you can change the column name also. Now there are two ways to DF is this, na? DF was formed using this dictionary. Yeah, this is a data frame. Pandas data frame. Fine. Yeah, we just use PD dot data frame, and inside this, whatever you will pass, that would become a data frame. And no, then you can directly work on the data frame. DF dot whatever you will see, you can have many things related to this only. Here it's not showing, but yeah, all directly you can work on the data frame. Okay. So now we have, let's see. Okay, let's see. Um, 1 second. Let me open. Let's say we want to get some data, which is not this much simple. Let's take some other data. Um, let's see what we can take. Okay. No, I'm sharing the screen. Just a second. Let me take out some data for you. Okay, let's say you have this data. Okay, this data is available online only. Okay, this, let's say, this electrical vehicle population data. Fine. Let's copy the link address. Okay, let's put it here. Now I'm using this command wget. I can download. You know, let's see. Yeah, yeah, in every using this, this exclamation mark, you can run system commands basically. So because this is a Linux system, so you see Linux commands are possible. If you are working on a Windows, then using exclamation mark you can run Windows commands. So if we see sample data, this is Google Colab, na? So this is online only, and even you can go to the. Uh, so there should be a way to go to the terminal as well. This is coming in between actually. Yeah, here let's see this. You see there we have sample data. We also have this sample data. Let's take this. Let's forget this for now. Let's take this. Okay, so import import CSV using pandas. Okay, let's say pd dot read CSV is the function. So for any CSV, you can use this function. And let's say California housing data set, housing train.csv. And because if you see the size of this data, so using len function, length of the data frame, you can see how many rows are there in this data frame. Okay, you see how many rows are there. Okay, currently if we ran it on this data, you see this, if we created this dictionary, then how many rows were there. Okay, so here you can see there were only 4 rows. But when we are importing this data, so you see there are around 17,000 rows. Now I don't want to see all the rows at once. I just want to see, let's say, top 10 rows or top 5 rows. So if you just do a df dot head means what? Give me top 5 rows. By default, it gives 5 rows. If you put 10 here, so it will give you top 10 rows, 0 to 9. And what all are the columns? Longitude, latitude, housing median. So this is housing prediction data set. Okay, if you want to predict the house price, you can do that using all these columns. Okay, so let's see, this is the data that we have. Now df dot head, we can show, we have just used pandas read csv, and using this read csv we were able to load this csv data into a pandas data frame. Fine. You can also do a tf.tail for seeing the end of the data frame. Yeah, last 5 rows. So you see last 5 rows are visible. Let's say if you want to do, if you want to see certain info of this data set, so you see, you can also use the df.info. What info would give you? The how many entries are there, what is the index, okay, how many columns are there, then each column has how many non-null values, what is the data type. So you see all columns has float data type. Fine. And this is the memory usage. Then you can also use df.describe. So info gives you this kind of info. Describe gives you statistical info, like what is the mean of latitude, mean of housing median age, mean of total rooms, okay, mean of total bedrooms. Yeah, standard deviation, minimum value. This is 25 percentiles, 50 percentile, 75 percentile, maximum value. Make sense? Okay, good. So this is used in what? Ah, so you see now, yeah, everything is ready made. You just import the data, everything Pandas is already having. Very easy. So now let me show you more functionalities for Pandas. Let's say we have created the data. Now let's say we want to check what all. So let's say we want to, let's take another data set, that is more interesting. What is this? Scomble.json MNIST data set. Okay, let's take some data set from the internet. Okay, let's see this data set. Let's download this data set. Okay, this has download, this will get downloaded, and then we will upload it on our Google Drive. Let's upload this. This is getting uploaded. So you see everything is happening on the Google environment, nothing on your local. So you go to this Google Colab, okay? Just click on this link and you will be redirected to this. Now this environment is something which Google is providing you. This is not happening locally. Like we saw that day we had to install Jupyter locally, na? So this is different. Now we are using Google Colab. This is online interpreter. You see RAM, everything Google is providing. But don't use your company data set here. Okay. Only use whatever is there. Or if you have your company account, so use your company account for Google Colab, and just using that you can use Google Colab. Then to it's fine. So this is getting uploaded. Just a second. Linux download CSV file from link. Let's see how we can download. Okay, curl, fine. So we can also use the Linux functionality to speed this up. Okay, let's say electric, and link is this. Very good. Now you see this would be running very fast. Fine. So we have, electric.csv. Huh? You see this? Now let's do df pandas read csv, and we are using electric.csv. I think this didn't got read correctly. Let's do a cat of electric.csv. There should be an option for terminal also. Hmm. Okay, part of it got downloaded. Okay, so this is the population, electric vehicle population data. So what population is having electrical vehicles? Okay, this is present in a CSV. Fine. Now you see what all columns it is having: county, city, state, postal code, model, make, of the electric vehicle, the type of electric vehicle, range of that, ID, location, and all those things. Fine. And how many records we have? Let's see, 44,000 records. Okay. Let's see the info. Fine. So now you see there are also some null objects for model. Fine. Chalo, we will not worry for that as of now. Let's go and check, let's say, df, and we want, yeah, so these many records are non-null. Like I'll show you, let's say model, let me take df, where df on model uh, is NA or is NA is outside. Yeah, fine. So you see, this would give me all those records where the model is NA. So you see this NAN. NAN means not a number, means this data was not present in the CSV. So for these rows, the data was not, for these columns, the data was not present. Okay, other data is present. You see, all other columns are having the data, but this column is not having this data in certain rows. Fine. Here it was showing na that total are 44,000. Out of 44,000, 43,000 are non-null. Means around how many? 1,000 or not on 1,000. Around 60, 70 rows are null. है ना? So that only dot is NA. Yeah, this is NA tells that if the, I'll show you. Yeah, let's see this. So this would actually go to, let's say, this DF model. Okay, this DF model has how many rows? 44,000, है ना? Now this, if I do an is NA function, so what it would do is it would go to every row of this panda series and check if the value is null or not. let's say let's check for first 10. You see first 10 values are what? This. Anything is NA, null. Anything is null, nothing is null now. So what it would do is NA would just return false. Fine. So this is what is NA is doing. And null rows. Fine. Now for understanding this better, what I want to show you, let's see how to filter a pandas data frame. Let's understand how to filter a panda. So df is the data frame. You use this square bracket for filtering. Okay, earlier what you were doing, you were just using, let's say, model or make, you know. But now what you will do is you will again use df. You will choose the, let's say, model is equal to, let's say the model is what, let's check, model 3. Fine. We want to see how many, we want to filter out the data frame which has this data, where the model, this is the panda series, wherever this panda series is having the model 3, filter out all the rows for that data frame. So you will not just see model, you will see the entire data frame. So you see around 84,000 rows has model is equal to model 3. You see model is 3 everywhere. But you are not just getting this panda series, you are getting the entire data frame. है ना? So this is how we filter a pandas data frame. If you would have just ran this, this would just give you what? True and false for all 44,000 rows. है ना? This would give you a true and false for all 44,000 rows. Now, wherever this is true, I want df to be returned. Wherever this is false, I don't want df to be returned. Like we were doing that numpy thing, you remember when we provided that boolean index. Similarly here also that boolean index is only working. If you see this here, inside this what I do, I usually provide the column index, है ना? But here what also I can do is I can provide an array, let's say true, false, true, false. See this now. What happened? But the issue is that I have to provide this true, false 44,000 times, because there are 44,000 indexes na, 44,000 rows. So this would mean that include this row, don't include this row, include this row, don't include this row, 44,000 times. Make sense? Let's say I'll show you one more thing. You can also do expand a, you know uh, list like this. So if let's say true and false is there, you can do that into 10, and you can use this also. Or but let's not get confused, so you can simply also do this true 44,015 times. It will give you all the data. And if I just do false 44,015 times, it will give me nothing. Make sense? Basically, wherever it's seeing a true, that row it is selecting. No, let's say the make is Tesla. I just want to take all the data where the make is Tesla. So wherever this would be true, it would select those rows. है ना? So around 20,000 rows have make Tesla. DF of what? No, DF of true means nothing. You will have to provide a list, actually a list of 44,015 elements. Like in NumPy we used to do, na? Let's say we have this ARR is equal to np dot array, na, we and let's say 1 2 3 4 5, है ना? And what we used to do is true, false, true, false, false. So what it would return? Hmm? We use that boolean indexing, na? So wherever it was true, it returned only those elements, है ना? Those values. These are the values. If you see, these are the values. N and 3. Fine. Similarly, like we used to do this in NumPy, same concept is being followed in Pandas. But here the rows are too many. You see, 44,000 rows are there. If we had this data frame, let's say the original one, this data frame, okay. Now this is having what? You see, this is having, oh sorry, yeah. This is having only how many rows? 4 rows. Now I can again use that NumPy like indexing. So what this would return? See, Akash and Palak. Now rows are, here are how many? 4. But if my rows are only 44,000, है ना? Here what I could have done is for filtering, see, I would have done df, let's say name. See what this would return if df name is equal, df section को लेते हैं, if df section is equal to a, ना, true true false false. C section is A here and here. True, true, false, false. Now provide this as an Boolean index, because you see true, true, false, false is only coming. So now what we will get? All the rows of DF where section is A. Make sense? Now same thing we are trying to do on a very large data. When make is Tesla, when model is 3. Okay. So this is how we filter pandas data frame. Great. Now let's import this data again. Now one more thing we can try, very interesting. You see, now df, let's see, make dot value counts. This function is very useful. M is capital. This function is very useful. You see, using this value counts, this is a what? This is a pandas series, है ना? Using this value counts, I can count the different number of values that are present in pandas series. So in this pandas series, 20,000 times I will see Tesla, 4,000 times I will see Nissan, these many times Ford, BMW, and all those things. Like we have make, we can also check for, let's say, electric vehicle type, how many different types of df electric vehicle type dot value counts. Now what would happen? You see, we have around 33,000, 34,000 electric, battery electric, and 10,000 plug-in hybrid electric. So using this value counts function, we can actually check the different values that are present inside my pandas function. Okay, we can also try this on our original, this small data frame. Let's try it here. Let's say this is SDF, small df. Let's see. SDF had what? Let's say section. It had section dot value counts. Now see what it would get. How many times A? Two times A. How many times B? One time B. How many times C? One time C. Fine. I'm showing you with actual data as well as with some dummy data, so that you can understand the actually why these functions are required in real world. Okay, make sense? Great. Not after some time we'll also see how to visualize this. So I'll let me show you how what we will do. This is just for demonstration. Okay, don't get confused. I'll show you. Let's say, so why this is very powerful. This value counts. That is what I'm trying to show. We'll do a bar plot of. Okay, just a sec. We'll do start reset index MDF. Hmm. Now if I on bar plot, x is equal to x, y is equal to make, y is equal to what is it? MDF. See, as axis rotate, we can rotate the axis. So we just need to do a small thing. Just a second. I will show you this also. Hmm. Just now is it fine? Matplotlib.python has priority. Hmm. See, using value counts, if you want to show this to someone, है ना, that in your data how many Tesla vehicles are there, how many Nissan vehicles are there. So rather than showing just the plain data, you will show this kind of output. Fine. And this would make it. Let's put it here. This is just for your reference. Okay, don't get confused like how we are doing what we are doing, just for your reference, that what how why this is very powerful. See, now everything is visible also. Very good. So now we have seen value counts, we have also seen filtering of pandas data frame. Okay, now after filtering you can also get a single column also. Let's say you have this df make is equal to Tesla. Okay, simply if I take this, what would happen? I'll get the entire data. है ना? Now, if I just want to see, let's say, the electric range of all the Tesla vehicles. Okay, I just want to see the electric range of all the Tesla vehicles. है ना? Then I can do it like this. So now I'm filtering the data first and then selecting the column to see. I can also do a mean on this simply. Mean electric range of all Tesla vehicles in our data is this much. And now we can see this also. Let's sum it up to the. Now, if you want more than one columns, then you can do it like this also. Then for more than one columns, it would become a pandas data frame, है ना? Because pandas series is a single column, but whenever we move from one to many columns, it becomes a very good. So let's take this. Let's take electric range and electric vehicle type. Whenever we are doing a data frame, filtering out a data frame, there are two square brackets. Okay, one for the data frame and one for selecting the index. Just remember two square brackets are required whenever you want a data frame after filtering. If you want a single column or a panda series, you just use the name of the series. But if you want a data frame, you will have to do it like this. So you see, now we also get the electric range. We also get the electric vehicle type of all Tesla vehicles. Fine. Okay. So any doubt in this? Let's delete this section. Fine. Okay. So yeah, this is. I think we will sum it up today for this much only, because I think we have covered a lot many things, and this would try now. I'll share this notebook as well. I'll share the recording as well. Not try to implement all these pandas functionalities on any of your data set. Okay, whatever data you have, or you can get it from this kind of online catalog.data.government. You see, there are many data sets present here. Try these simple things like getting the mean value of any vehicle, or whatever data you are using. Try getting the mean values. Try extracting the you know how many times different things are coming. Use value counts. Use uh, filtering. Use you know getting the column, getting the understanding describe, understanding info, head and tail. Try everything on a new data set now. Okay, and in the next we will be meeting on Friday. Yeah, day after. Day after tomorrow we will meet now. Okay, till because how many? No, I can take 2 hours, but it's just that I want you to practice along, because this content, if anyone else would teach this content, they would take 2 hours only. But I usually teach it in a way so that in less time we can cover more things, and you have many things to try. Okay, but yeah, Friday would be a bit longer, like 1.5 at least we will try, because we will. But you need to share one, this kind of pandas notebook or Jupyter notebook with any of your data set, whatever data set you want, or if you want to me to give any data set, we can do that also. Okay, so you can take any data set, download it, use it, and if there's any issue, you can connect on WhatsApp. Okay, ciao.